Hello and welcome to the second session of Foundation Mathematics, where we are still discussing the theory of sets. Once again, I'm your host, Upe Kolosa. So, if you watched the previous session, we discussed the definition of a set, as well as the characteristics of the set and some basic notations that we are going to be using for the rest of this unit. Well, just a quick look up on the characteristics we mentioned last time. We said for any kind of collection of objects to be called a set, number one, we said it must be well defined. Maybe let me just be writing one or two things. So on the characteristics of the set, we said for it to be called a set, number one, we said it has to be well defined. So what this simply means that if you are dealing with the set of oranges or the set of fruits, it should just be fruits. That is a collection where you are having a mango, a guava, or any fruit. If you are dealing with a set of numbers, it should only be a set of numbers, not whereby you are combining the numbers and the fruits. That means that collection is not well defined. But one of the characteristics for a set, we said a set must be well defined. Then the second characteristic that we mentioned was that the elements in the set must be distinct. So number two, we said the elements in the set must be distinct. That means that the element, if you're having the element 2 in a collection of numbers, that 2 should only appear once. If in that collection you have a 1, that 1 should appear once. And the example that we can give is if you are having this collection of numbers, you have a 1, 2, 3, 4, 1, 2. And we are saying that this kind of collection is not a set because we are having a 1 which is appearing twice. We are having a 2 which is appearing twice. So for it to be called a set, these elements must be distinct. That implies the 1 is going to appear once, the 2 is going to appear once, you have a 3 and a 4. That defines what a set is. Then the third characteristic that we looked at is that for a set, so let's say the third, number 3, we said that the order of elements is not important in the set. The order does not matter. Whichever number you begin with, or whichever letter, if you are dealing with the alphabet, whichever letter you begin with is not important. So for example, we can have 1, 3, 2, 6, 5, 4 to be called a set. The order does not matter. You can as well write these numbers in ascending order. So now, keeping in mind these characteristics, in this session now, we are going to describe the ways, or we are going to talk about the ways we can describe a set. So there are 3 simple ways of which we can describe a set. And of these, the first one we can look at is the listing method or the listing approach. So this approach simply lists all the elements of the set, provided its elements are known explicitly, you can say. Let us look at how, or the some of the examples of sets you can list. So by explicitly what we mean, what should be in the set, what is in the set is what is known and can be defined, it can be listed. If you are dealing with a set of numbers 1, 2, 3, 4, we are able to recognize that these are numbers. If it is 1, 2, 3, 4, obviously the counting numbers. If you are dealing with a collection of fruits where you have to have this collection explicitly defined. That is, you need to know that this is an apple, this is an orange, and this is a guava. So let's consider we have A to be 2, 4, 6, and 8. We can also consider we have our B. This is B, not 13. We have our B that is starting from, maybe we can start from a 0, 1, 2, 3, comma, dash, dash, and dash. I hope by now we know when we have the 3 dots at the end of any listing, that implies the number keeps on going and going. So now, what do you say about set A and set B? You can say that A is the least of these members. That is, you are given a set A. Describe what is in set A. So let's, or perhaps I do this. 1, 2, we don't have a 1, so 4. You have a 6. You also have an 8. This is your set A. Then we ask you to describe set A. And we are saying the easiest method you can use to describe set A is where you list them. These objects that are in A, remember we say that the objects are what you are calling the elements or the members. So to describe this set A, you are basically going to list the members that you can see from set A. You also have set B, where you have a 0, 1, 2, 3. But we are saying that these numbers, they keep on going to an infinity. You don't know where they are ending. And you know that infinity can be n big number. So, using this method of listing, are you able to describe the set where the numbers are going to infinity? Okay, keep that question in mind. However, note that listing uses the curly brackets. So remember, we represent a set using the curly brackets, like that. Even listing, we are going to be using the curly brackets, and all the members that you have in set A are going to be separated by the commas. So listing, you can say, is a very effective and simple approach of describing a set. Let's take, for instance, you are asked to describe a collection containing 4 fruits. In this case, we use listing, where you basically list the fruits in the collection. You can present, let's say, the collection that you have is a bag of fruits, which we are going to call F. So consider you have fruits in here that you are able to see. 4 fruits, like we said. How do you describe these fruits? You can use a set, or you can use the listing method, where you say, if this fruit you are seeing here is an apple, you are going to say apple, then separate with a comma. You go to the next fruit. If the next fruit that you are seeing there is a guava, you are going to say guava, again, comma. Third fruit, if you are seeing an orange as a third fruit, you are going to say an orange, comma. Finally, you have the fourth fruit, which is a mango. So this is how you are going to list or to describe set F by listing. Now, let's go back to set B. Despite this approach being the easiest, it can only be applied to sets that are countable. What do we mean? If we look at set A and set F, they have one thing in common. In set A, what we were able to see are 4 numbers. In set F, what we are able to see are 4 fruits, meaning we are able to count the members that are in this set. However, for set B, we are not able to count. How many members do we have? We said we have a 0, we have a 1, 2, 3, and we said this dash, or these 3 dots, implies that the number keeps on going until they reach an infinity, and we know that infinity can be any big number. Therefore, we are not able to count the elements that are in set B. Therefore, you say this listing method is going to be used when you are dealing with countable sets. This is when you are able to count the elements that are in that particular set. Now, in math and science in general, we encounter a lot of sets that are not countable, yet they are very useful. Since listing cannot be applied to such sets, there must be some other methods that we can use to describe such sets which are uncountable. And this takes us to the second way of describing a set, which is called the describing of the elements. So that is the second method of how we can describe a particular set. Now, what happens in this method? Basically, this approach involves making a descriptive statement of the elements that you see inside a particular collection. Remember, when we are having the previous example on listing, we had a set that contained a mango, a guava, an orange, and apple. What are these? What are these elements? What do they have in common? You say, this is a set of fruits. Well, you've described a set. As simple as that. It is a set of fruits. So let's take another example where we have our set A to be 1, 2, 3, 4. Maybe we can end here. For clarity's sake, let's have 1 more or 2 more examples. Set B, you have a 2, 4, 6, and 8. The last one, let's make it a little bit different, where we have a 0, 1, 2, 3, and the 3 dots at the end. So look at the sets. If you look at set A, B, and C, set A and B, these are countable sets. We are able to count the elements that are in it. Set C, it is an uncountable set. We do not know how many elements are in it. So we can describe set A and B using the listing method, as we've discussed. But how do we describe C? This is where now we are going to make a descriptive statement on the elements that are involved. Well, let's begin with A first. A is the set of natural numbers from 1 to 5. We know that these 1, 2, 3, 4 up to 5, these are counting numbers, which you call the natural numbers. So using the second method of describing a set, you just say that set A is a set of natural numbers. Let's use this N to describe the set of natural numbers from 1 to 5. Remember, there are so many natural numbers. You need to be explicit where you describe what you can see. So we are having a set of numbers from 1 to 5. How about set B? How can you describe set B? B, they are also numbers, and you'd say set B is the set of even numbers from 2 to 8. As simple as that. So you say B is the set of even numbers from 2 to 8. Be as explicit as possible. Describe what you can see. From this description here that we have, we should be able to go back and list. That's how it works. Any descriptive statement that you make, you should be able to take back to a listed set. Well, what about C? You can say that since we know that C, you have the number 0, 1, 2, 3, but you don't know where it is ending. But you know the numbers or set of numbers that starts from 0, 1, 2, 3 going up. These are not the natural numbers, but they are the whole numbers. So how do you describe C? So C is the set of whole numbers from 0 to infinity. You don't have an ending here. The numbers keeps on going. So you say C is a set of whole numbers. Whole numbers from 0 to infinity. Even if I don't include this range 0 to infinity, if I just say C is the set of whole numbers, we know that whole numbers are the numbers starting from 0 going. So it's okay even if you don't include this range. So now we can see that we are able to describe this set C that we defined to be uncountable set using the describing of the elements method. Now, the beginning I said we have 3 simple ways. What is the third one? The set builder notation. The set builder notation. So this is the third and most important approach we can look at is this set builder notation, which is basically the more general approach in describing a set. Why would we say it is a general approach? Remember, listing we are dealing with countable sets. Describing the elements, we are using or we are dealing with uncountable sets. Now, the set builder notation, it is the general approach that is going to combine these two types of sets. So how do we use this approach? Like listing, it also uses the curly brackets. So using the set builder notation, we are going to use these curly brackets. Okay? Let us look at some examples that will demonstrate the use of the set builder notation to describe different kinds of sets. Let's look at the examples. So let's go to the next slide. Yes. So if sets A, you have the set A there, which is an uncountable set. You have set B, countable set. And set C, guess what set it is? It is also a countable set. A, E, I, O, U, those are vowels. Describe the sets A, B, and C using the set builder notation. Okay, so this requires us to describe using the set builder notation. How do we describe this? Remember, set A, uncountable. We can describe this using the listing of elements, of course. Set B, countable. Using, yes, the list of elements. Set B, we can describe the listing. Okay? So now, describe the sets A, B, and C using the set builder notation. So, let me describe them, then I show you how we read or how you can describe. So let me first write where I'll say A. Remember we said just like listing, the set builder notation is also going to be using the curly brackets. So here are your curly brackets. Okay, that is A. Then I'll say X with the line there separating my left and the right. And what is going to be on the right of X? I'll say X greater than 3. Okay, what else can I see? I'll say this X is the member of. Remember, on the notations of sets, we defined what the member of means. Then I'll say the natural numbers. Why have I said this? Think. Take some time, you can pause the video and think of what is happening. Well, as you are thinking, let me also put our B here. I'll say X like that. Then I'll say 1 less equal to X less equal to 5. Okay. What else can I say? This X belongs to integers. So the Z there represents the integers. Finally, let me have my C here, where I can put T such that, what can I say about T? T is A, E, I, O, U. What you call the vowel. So now, what is set builder notation? What are you seeing from these examples and from the things that I've written? So a set builder notation, if you are dealing with numbers, it is going to contain of 3 sections. Again, a set builder notation, if you are dealing with numbers, it is going to contain 3 sections. The first section is the section that is before this line. That is your first section. Then the second section, remember I said if you are dealing with numbers, the second section is going to show is going to show the range of these numbers, where they are starting, where they are ending. So this is your second section. Then the third section is going now to show where these numbers are coming from. Same things on B. B is a set that is having numbers. Again, it is going to have three sections. The first section, you have X here. What is now this section, the first section, the one I'm calling the first section? So this is going to be any arbitrary element or any arbitrary letter that is going to be representing these elements. If I say X, such that means X can be anything from this set. Okay? So X is an arbitrary. That's why on set C here, describing set C, I've used T. Perhaps I would have used Y here on set B. So we can have an Y, a Y there, a Y there. So Y can be anything. So now if we are dealing with the letters instead of numbers, the set builder notation is only going to have two sections. The first section is an arbitrary letter that is describing an element that belongs to C. Then such that, this line implies such that you now describe what your T is. We don't need the range because we are dealing with letters. So you just describe where these letters are coming from. So any letter that is in C, that is your T, is a vowel. So again, you can say, or the way you can read it, the expression A is read as A is the set of X such that X is greater than 3 and X is a natural number. Similarly, you can do the same thing with B, where you say B is the set of elements Y such that 1 is less or equal to Y, yet this Y is less or equal to 5, and X belongs to the set of integers. Then the last one, C, you can read it as C is the set of elements X such that X is a vowel. Well, in this session we are going to end here. In the next session 3, which will be the third session, we are now going to look at more examples of how you can describe a set builder notation. Remember to get a quick notification when videos are posted. Remember to like and subscribe to the page Ope Colossa. See you in the next session.